Good morning, everyone. Myself, Jagendra Singh, and I'm the author of this paper. The topic of the paper is anticipating graduate program admission through implementation of deep learning models. Paper ID being 468. The abstract of my paper is acceptance into a graduate program must be a part of a student's academic journey. Every year, a huge number of people apply to schools and universities, and the admission process may be tough and time consuming. Many factors are considered while evaluating a student's application, including academic achievement, test scores, LOR, and extracurricular activities. However, selecting the best choices can still be arbitrary and prone to mistakes. As a result, it is required to develop a more efficient and objective technique of evaluating an applicant's chance of admission to a graduate course based on their application materials. The purpose of this study is to develop a ML model that can predict a student's prospect of acceptance into a graduate school. The model will be trained using a dataset containing different characteristics such as GRE scores, GPA, and letters of recommendation. The dataset will be pre-processed to cope with missing values, outliners, and categorical data. A variety of ML models, including LR, DT, and SVM, will be used to build the model. The algorithm's efficacy will be measured using a variety of measures, including accuracy, precision, recall, and F1 score. The best performing model will then be picked and used to evaluate the admissions and outcomes of fresh applicants. Let me introduce to a paper. Graduate admission is a highly competitive and sought-after procedure that shapes an individual's professional future. Given the number of factors involved, predicting the chance of admission may be a difficult undertaking. However, with the introduction of machine learning algorithms, the admission prediction process has become more accurate and efficient. In this paper, we will use five different ML models to estimate a candidate's chance of admission. SVM, gradient boosting classifier, random forest classifier, k-nearest neighbor, and logistic regression. We employed a dataset that included information on a candidate's academic history, test results, and research experience. As extra factors, we analyzed the candidate's SOP and LOR. The initial stage in our investigation was to pre-process the data. We began by cleansing the data and dealing with any missing or erroneous numbers. Following that, we used feature scaling to guarantee that all variables were on the same scale. After that, the dataset was separated into training and testing sets, with 80% used for training and 20% for testing. The five machine learning models were then trained on the training data before being tested on the testing data. It is well known for its accuracy and capacity to handle large data sheets. We discovered that the model performing exceptionally well in forecasting the chance of admission based on the candidate's academic background and test results in our research. Our research also found that the SOP and LOR has a considerable influence on the chance of admission. This is consistent with earlier research that has demonstrated the significance of these characteristics in the admission process. These factors were captured by the random forest classifier model and used to create correct predictions. Finally, this experiment shows how machine learning models can estimate a candidate's chance of admission based on their academic history, test results, SOP, and LOR. The random forest classifier model predicted admission with excellent accuracy based on a candidate's academic history, test scores, SOP, and LOR. This research has significant consequences for both universities and applicants, as it may assist institutions make better informed judgments about the candidate they accept, and candidates evaluate their odds of admission and make educated career decisions. This is the methodology. The method reads in a dataset called admissionpredict.csv using pandas library and conducts some initial data analysis. It checks for missing data using the isNull function and generates the descriptive statics using the describe function. It also plays the dataset column names by utilizing the data frames columns attribute. The serial number column is then removed from the dataset because it is irrelevant to our investigation. The goal variable chance of admit is then separated from the predictive factor. Then using the standard scalar function from the scalar package, it applies standard scaling to the predictor variable to guarantee that all variables are on the same scale. The scale is fitted to the training data and the same transformation is applied to the test data. Finally, it uses the sklearn package to import four regression models: linear regression, SVR, random forest regression, and gradient boosting regression, based on academic and personal information. These models will be used to forecast a graduate student's chance of admission. After partitioning the data into training and testing sets and scaling it, the codes use the training data to create and fit our four regression models: linear regression, SVR, random forest regressor, and gradient boosting regressor. The code then predicts the target variable values using each of four models on the test set. Logistic regression (LR) is a form of supervised ML technique used for classification issues with a binary output variable, one of the two potential values. Support vector machine (SVMs) comprise supervised machine learning algorithms employed for classification, regression, and detection of outliers. K-nearest neighbors (KNN) is a form of supervised ML that can resolve classification and regression issues. Random forest (RF) is a form of ensemble ML method that may be used for classification as well as regression. So these are proposed approaches. The method begins by reading in the data with pandas and performing some preliminary data analysis, such as checking for missing data, creating descriptive statics, and eliminating an unneeded column. The target variable is then separated from the predictor variables and the data is divided into train set and test sets. To guarantee that all the variables are on the same scale, the predictor variable are scaled using the standard scalar method from the sklearn package. The method then develops and outfits four regressions models to the training data: linear regression, SVR, random forest regressor, and gradient boosting regressor, and each model predicts the target variable for the test set. The ask-wide score for each model is then calculated using the test set actual and predicted target variable values. Data processing. Before we can create machine learning models for graduate admission prediction, we must first prepare the dataset for analysis. The following are the preparation process conducted on the dataset. Feature extraction, the process of choosing and modifying input variable features to improve the performance of ML models, is referred to as feature extraction in the context of graduate admission prediction issue. The original dataset has the following characteristics: GRE out of 340 score, TOEFL out of 120 score, out of 5 university rating, SOP statement of purpose, strength 5 points, LOR letter of recommendation, strength 5 points, GPA out of 10 for undergraduate studies, experience with research either 1 or 0, admittance chance from 0 to 1. Datas This is the experiment. Dataset: the graduate admission prediction dataset is made up of several criteria that are considered when applying for master's program at institutions. The dataset is made up of 500 rows and 9 columns. The columns are as follows: the graduate record examination (GRE) is a standardized test necessary for admission to most graduate programs in the United States. It is graded in 1 point increments from 130 to 170. TOEFL score: the TOEFL measures non-native English speakers' ability to use and comprehend English. It is graded on a scale of 0 to 120 points. Statement of purpose (SOP): a student-written essay that describes their academic background, research interests, and career ambitions as a part of application process. On scale of 1 to 5, it is rated. A letter of recommendation (LOR) is prepared by a faculty member or supervisor who is familiar with the student and can speak to their academic talents and potential. On a scale of 1 to 5, it is rated. These are the results. Results computation. We have built models with an accuracy range from 85% to 90%, 98% at different times for predicting the results. We reached the highest accuracy level using gradient boosting classifier. In this paper, we have explored several machine learning approaches. We have shown the result of the practical implementation of the proposed models. For better understanding, we have even demonstrated the accuracy of the proposed models over a bar graph for a better experience. You can see this bar graph that represents the accuracy score. Results. So these are the results. The parameters are true positive, false negative, true negative, false negative, accuracy, precision, recall, FN score, misclassification rate, true positive rate, false positive rate, true negative rate, prevalence, null error rate, negative predictive value, false omission rate, Jaccard index, Matthew correlation coefficient, and based on all these factors, we give a rank. In conclusion, finally we investigated a graduate admission prediction problem utilizing a variety of ML techniques. To prepare the data for analysis, we began with the data preprocessing and feature extraction techniques. Following that, we investigated 5 different ML algorithms: LR, SVM, KNN, RF, and gradient boosting. According to our findings, the gradient boosting techniques outscored the other 4 algorithms with an accuracy score of 0.97. Lower accuracy values were from 0.85 to 0.93. For the logistic regression, decision tree, and random forest methods, it is crucial to note, however, that the performance of these algorithms might be enhanced further by tweaking their hyperparameters. So thank you. Here I'm over with my PPT.